Hi everyone, Dan Gunner from Insane Forensics. Welcome back to Tech Talk Tuesday, where every week we try to give something to help your security program. And this week, what we're going to talk through is ELITEWOLF, which is a set of signatures that NSA and CISA released last week. We'll talk through what they are, we'll talk through what's in them, we'll talk through how to tailor them to your environment, and then some improvements you can do to improve the quality of them and make them a little more successful for you. So last week, NSA and CISA released an advisory called ELITEWOLF. It referenced back to an NSA publication from July 2020. The purpose of this really was targeted towards industrial asset owners, and the idea was to give them a set of rules to help detect potentially malicious bad things. We'll throw in that potentially malicious in there because, again, the goal of this is there's still going to be human involvement. Unfortunately, this isn't just a rule set you can drop and step away from. There still is going to be a human component of this. And so part of our talk today, we wanted to talk through what the human component currently is and then how you can kind of balance how much you have to step in for it. So again, NSA put this out both to help critical infrastructure, defense industrial base, and national security systems respond to these. This was a follow-up to the report I mentioned from now almost 3.5 years ago. So let's dive deeper in. Of the rule sets, so they put them up on GitHub. There's 3 text files focused on 3 specific vendors. First one's for Allen Bradley for Rockwell Automation devices. Second for Schweitzer Engineering Labs. We'll see as we talk through those rules. That's actually a really interesting set because in there, they actually get into SEL's proprietary protocol, which is an extension of Telnet, and how to deal with that. Third rule set of this is the Siemens rule set. And as we said, something to be very, to be very aware of as you go through this rule set is this disclaimer that these rules are designed to kind of help find things that may be good, may be bad. Some of these rules, there's kind of a balance between how loud is this going to be if you stick it out on the internet or if it's an internet-facing device. With things like Shodan, with just the amount of open scanning, you're going to get a ton of rules, right? Hopefully most of your industrial devices aren't out there. There still are a lot that are. But again, it's kind of important to understand the balance with that kind of major disclaimer that they provide in there, and we'll talk through that. So we'll dive through the first 3 sets of rules, what they put up. We'll talk about what they detect. And the best set of rules that I thought in here was for Schweitzer Engineering Labs. And so Schweitzer Engineering Labs, also known as SEL, they make a variety of devices seen both in substations, you see them in refineries, you see them in power generation. And these rules specifically actually focused on they focused on very specific models of SEL devices. So you'll see in there 3530, 3620, 2488. A lot of these rules are focused on X509 certificates or SSL certificates that these products use as part of their web interfaces. These certificates often have strings in them that either can tie you down to a specific model, they can tie you down often to a vendor. But what these hone in on is, hey, we can look at X509 rules and say, okay, if I see this string coming back from this web server, then it might be an SEL RTAC in that case, right? Because of where these rules are put, these are purpose-driven networks, and so you can get away with, there kind of being less noise in strings. You can also get away with, hey, there's hopefully not, cross fingers, a whole lot of, there's not a lot of deception out there. And so, with kind of being purpose-driven with lower deception, what these rules look for is very specific certificates tied to those SSL connections on the server. It's also important to note, if you look at the case of the rule, your source direction is actually originating from 443. And so this is looking for response packets. This isn't actually looking for the request packet, right? This is important to know, right? Because you're only going to see responses on there. And so, the first 12 rules on this tied to very specific URLs and X509 certificates. Now, the 21 rules after this, and this is where it gets really interesting and where I like this rule set, is there's 21 rule sets tied to what's called SEL Telnet. And so to manage these devices, SEL created a proprietary protocol that's an extension of Telnet. If you look at the Telnet protocol in Wireshark for SEL, there's a lot of strings in there, as SEL has adapted the protocol. And what these rules specifically look for is, operations in these strings. They look for things like, if you look at the bottom two rules in there, you'll see a default user and default password. So yes, they're even detecting default password usage in here. The password is really just tail by default on a lot of these devices. And so to that point, what's interesting about this rule set is the folks over at NSA did a great job taking a proprietary protocol. It's very clear they had access to this in the lab, as you would expect from any well-funded nation state to do that. And they were able to say, hey, looking into these strings of SEL's Telnet protocol, here are ways to identify devices, identify critical functions, identify things like access level changes, look for default passwords, because again, it's just Telnet, so it's straight out in the open. There's no encryption, there's not going to be really any of that there, right? Strings here, some of those strings specific to models might be specific to that model. They might work for other things. Some other things we've done in the past with SEL web pages is oftentimes you actually get asset information, device model, sometimes firmware version, other things that go over HTTP or other protocols. And so, as you're testing these in your environment, as you're taking these rules, realize that yes, it is tied to SEL Telnet. You might need to tweak some things around. We'll talk about tweaking later, but it might work quite well and you might actually be able to widen it even farther out. Okay, so weaknesses on these, right? So rules are going to detect every time a page is accessed. There might be big alert fatigue with this. Again, I talked to some people and they're like, hey, Dan, this SEL Telnet isn't commonly used in here. These interfaces, when's the last time an operator went to that? That's fair criticism on there. Maybe your network is that quiet most of the time. When you get into turnaround or when you get into maintenance windows, when people are using this, if you do need that granularity, right, you might find yourself in a sea of data, right? So, definitely take a look in your environment, see where and when and how often SEL Telnet's used. Because again, my favorite set of these ELITEWOLF signatures is the SEL set, because there was a ton of homework that was done across this. All right, so we'll move on to the second part. So the Siemens rule set. So I also liked SEL because it's by far was the most complicated rule set in there. They went the deepest. This isn't to knock whoever worked on the Siemens side or worked on the Rockwell side. On the Siemens side, the rules are a little bit simpler. They're just looking at that port 80 or port 443 traffic. On port 80, for some reason, they only looked at the S7 1200. Again, this is where some of these strings, some of the web files that are used might also be on the S7 1500, might other be on versions. You might need to find some of your own strings to do this. But for whatever purpose, NSA decided to put out rule sets specific to strings on the S7 1200 on here. Top two look at specific things in HTTP. Of course, these PLCs do support HTTPS. They do support SSL. And so in that case, they go down to the certificate and default fields that are seen in that generated field. So again, the port 80 rules, the strength is to work with HTTP. If there's SSL, the TLS rules should kick in. The weakness on this rule set is, again, it's kind of a very generic set tied to the S7 1200 controller. There's a lot you might miss out there. And we'll talk later on other ways to find these controllers, other ways to look specific actually to the industrial comms traffic there. There's going to be massive analyst fatigue because if anyone hits that web server, if you have automated tools that are doing security out there, there are more active scanning tools in OT now. And so some of those tools are going to be caught in traffic. We'll talk later on ways to filter out IPs and do things. But again, every time that web server or resource is paged on the top rule here, they're setting it on s7web.css. Every time that CSS style sheet is seen in content, you're going to see a rule for it with the default rule sets there. Moving on to Allen Bradley, it's the same deal. Looks for very specific web server routes, specific pages, specific page calls. What is cool with this is they get down into different pages on the PLC. So again, it's very clear they had a PLC on hand and they were looking at the different pages likely as they were going through the PLC. So there's granularity to say, hey, on this PLC, this user went to this page at this time. The strengths here is the rule is going to detect every time that page is accessed, right? We're going to get it contextually tailored down to that. Again, the weakness though is you're going to get a rule every time that page is hit, right? So as you're filtering through, as you're finding context, your context on this being good or bad, you might be able to do it from the IP address, you might be able to do it from context there. Likely this is going to be a chain tied to something else. There's easy ways to tailor down some of these rules, and going beyond just what web page is someone hitting, right? So things we can do. So that was kind of a quick overview of the 3 types of rules that were put out. Now what we're going to talk to is we said alert fatigue. We talked about through some of the kind of strengths and weaknesses of those. How do we turn these rule sets, right? So a quick one we can take is take that default rule, and with Snort logic, one of the things we can do, because these are Snort rules again, is just start to add IP ranges. And so in that good rule, that's the one that NSA provided in the report. It's going from any server port again, because you see any 80 on the source side, so it's looking again for the response side, going to any with that S7 web CSS. If you're like, hey Dan, how do I filter out known subnets, right? One way you might do it is just changing on the other side of that arrow what we put in yellow there. We took the RFC 1918 addresses. So our RFC 1918 defines the IP addresses, which are private IPs that aren't used by the internet. These are the ones commonly you'll see at home, like 192.168 or 10.10 or those ranges of IPs. What this does is it says, okay, originating from any port 80 with that file, going to public IPs, right? You might change this IP also within the context of your network to say, okay, I know my IP schema. I know who should hit, this web page, right? I know who should access this CSS file. So in this case, you might use the public IP, or you might use knowledge of your network to say, hey, let me just go ahead and add a rule that says, this CSS file really shouldn't go to this random other part of the plant that shouldn't hit the web PLC, right? It shouldn't go to the business network. It shouldn't go, to this other subnet. That's one very simple change you can do. Again, you have to contextually understand, but this will save disk and processing. It'll save the size of your Snort file, how much you're pulling into a seam, how much you're pulling into other tools. And it's a very quick tweak that takes up the sophistication of your rules. On the flip side, and so that was a rule that used the CSS file. We can do the same with that certificate side. So again, take a certificate rule. Again, we can apply that IP filter you see on the top line. On the bottom line, the other thing we can begin to do is add what's called a detection filter. So this is where you have to be careful between Snort 2 and Snort 3. Snort 3 has detection filters. Snort 2 had threshold and detection. I think Snort 3 got rid of threshold. And so again, though, here you can set a detection filter track by destination IP, again, because the destination IP is going to be the most unique likely here. We can say, when you count 5 of these in 60 seconds, that's when you'll do the alert, wait for the alert, right? So again, depending on noise in your environment, you might change that count to say, hey, wait until you see 500 of these requests in a minute before you alert me. What it'll do is it'll reduce the size of what's getting put into your log file and save some processing time, and potentially down the road, depending on your tool chain and how your security operation works, it saves you from the amount of data you have to process on the back end. Now, something I'll note on here is you actually can use generative AI to do this. And so we took one of the rules in from there, and we basically said, hey, take this rule and narrow it down, right? So it properly added in that IP subnet. We just said, hey, give me the RFC 1918 rule set and what it looks like there. What is interesting here, though, is that I've noticed as we were working through this example, sometimes ChatGPT, and this is with GPT-4, sometimes it struggles with understanding the Snort 2 versus Snort 3 API. I've also seen this with Zeek. And so in this thread, it kept trying to go back over to thresholds versus detection, which aren't in 3. And so again, you kind of had to lead it over. But even if you aren't a Snort rule writer, ChatGPT can get you kind of in the ballpark a lot of times. And then what we usually do is have the documentation open, right? Or sometimes, like there were a few times where we just started from the documentation side and we're loosely using it. But generative AI can help you. It can help you brainstorm. It can help you also as you get into sophisticated side on this. So if we want to get fancier, so again, those were some very simple tweaks. If we want to get fancier, something we can do, so the good side, right? We saw rules tied to the HTTP interface. We saw rules tied to HTTPS, kind of based on that assumption of how often are people looking at web interfaces on the PLC, and trying to detect people that, maybe attackers that are looking specifically at those interfaces, right? But not all attackers are going to do that, right? They have operational security type deal, they have risk programs, and they might know, hey, it's really risky to go to that web interface, and so we'll just stay down on the S7COM protocol layer, right? So better, again, is to increase the alert scope and look for functionality tied to those operations, right? When we were looking at those Rockwell rules, and if you go through them in there, again, they have them tied to specific pages. Those alerts require people to go to those specific pages to fire. Well, someone can just connect to the PLC. It's probably not authenticated because most of them aren't, and make those calls without going through the UI, and you wouldn't know either way. What we pulled off on the right there is an image from NSA's report, right? And they actually gave, this was from the July 2020 report, they gave the top 6 commonly observed tactics and techniques. And so we're going to use one of those tactics and techniques to show how you can kind of take the approach ELITEWOLF is using and push down into that layer to where we're not just looking at web page visits. So getting fancy from that report, one of the things that they said is connecting to internet accessible PLCs with no auth, right? And a good way to do this, and off on the right there, you'll see Shodan screen because yes, everyone that's found Shodan and done a conference talk on it, there's a lot of opportunity, right, to find these open devices on Shodan. I don't think anyone would dispute that they're out there in any way. A good approach might be to say, hey, let me just look for traffic going to port 102, right? Port 102, and we're going to use a Siemens example here. Port 102 is where Siemens's S7COM port generally is that most S7 1200 PLCs use for it. And so one approach we might say is alert on traffic to that industrial port from a non-RFC 1918 IP. We saw this rule before, right? Alert, TCP. In this case, we're actually using the source, any port going to any destination port on 102. Other way to write this rule, if your home net's defined, you'll want to set home nets. There's other things you can do in Snort. We aren't going to get down to that. But on this rule, we're basically triggering now on any connection to TCP 102. Now, if you're familiar with OT protocols, TCP 102 is actually a very challenging port because not only is S7COM on there, but ISC 104 is on there, COTP. There's actually quite a few. ISC 61850 has some protocols, MMS and Goose use 102 out there. And so the challenge is with that good alert, if you just set the rule there and assume it's S7COM, there's no guarantee that it's S7COM, and in most planned environments, it's not likely to be even if S7com's there, because there's a lot of TCP port 102 traffic going on in S7com networks that isn't just port 102. So again, granularity on there is not very good. But what you can begin to do is tune that rule to S7com, and we'll talk through where the logic of this actually came out of. But again, you start with that, starting from external IPs, starting from subnets I don't know about, or that shouldn't communicate with the TCP 102 on this device. You can begin to set that content field in there to say, if you see this byte value, within this offset of the packet, if you see this byte set value within this offset of the packet, and we'll talk through the logic between those byte values and what's there. But what this gets into is the actual protocol and the layout of that protocol, and we can begin to set snort rules that have a much more accurate setting on looking for people using industrial protocols on TCP port 102. And so what this rule actually looks at, and so we talked about kind of the good and better. We pulled a PCAP from S7com traffic. This was from a network deal. What you'll see down there is you'll see that first content equals 03 within 50. What this is the TPKT header. And so as every S7com packet actually has two other protocols that it generally rides on. And so when you see that first check for content and you see the flat lines and then you see 03, it's looking for hex value 03 within the first 50 bytes of the packet. Generally, this version number for a COTP is always actually within a predictable number. So when you look at S7com traffic, it's generally always at the same offset. We've set a little bit of, we could say offset and then give it a specific offset. Here we've given it a range just to say somewhere within the first 50 bytes, but we're matching with that known value in that first header that doesn't change. When you go to that second arrow, so that was looking for the TPKT header first. The second arrow, we're going into COTP. There's a PDU type field, and so we wouldn't want to set on length, because what we'll find when we were talking about offsets versus withins, this part is variable. And so unfortunately, the function codes that are set at this part of the packet aren't always reliable. But again, we're still within, I think we set it in, within 10 bytes. Generally, it's still within 10 bytes of that other packet. Here we're looking for the function code F0, which is it's F0, which is what we commonly see. You see it 0F for DT data. There's two other values you can set in here that we didn't commonly see in our PCAPs being used. But again, we're setting down to say, hey, generally in this offset, your chance of having that first one and then the second one, you're statistically getting more unique with this. Once we get into the third, we're actually in our S7 communication header. There's always that value 32, right? So when you see that last content 32 within 20, that's looking for the value of 32 hex within 20 bytes of that last F0 value in this case. And so again, where this is powerful and where this is getting powerful to ELITEWOLF is these fields are generally going to be set in a proper protocol, right? And there's a chance you can change one of these fields and the PLC will take it, but there's also a chance to where you change these fields and what'll likely happen is the PLC will say, hey, this is a corrupt packet. As I'm checking what I'm getting over the wire, this doesn't meet the protocol specifications, so I'm going to go ahead and throw it out. Why this is getting fancy with Snort is we've just built a rule that you can use on that S7 1200 PLC. You can use on the S7 1500 if it's using S7com. Again, this is for S7com. S7com Plus is a different beast. But again, what we have here is a rule that's not just tied to, hey, is this a string in the web page? Is this a string in the X509 certificates? Tied to that fact of, hey, I can see this either coming from the internet, I can see this coming from another port. And so when we get to that NSA report of, okay, let's look for people connecting from internet accessible devices, this will do it. We can even get fancier with this. Something I'll say on the right was, on the left was the packet we showed before. One of the challenges that I'll give you with this is that, NSA used Snort. There's advantages to Snort. There's also disadvantages. We showed kind of the offset byte of, an understanding of the S7 protocol and getting these rules. It was simple. There were 3. If you look on the right, we pulled this actually from a security conference, from a PCAP, from one of the labs there. You can actually see, right? You'll see 8 or 9 arrows there. Those 8 or 9 arrows are those same fields that we were looking at in the offset. And you have the same 3 fields repeated through there, right? And so this packet will still hit on there because, generally the offsets are still there for the initial 3. But if you're not actually dissecting this, like Snort would struggle actually to do this, right? Because it's really just doing the pattern matching. So where if you have a tool that's actually doing the dissection, like this image we're showing actually comes from Wireshark, you might have to get a little more sophisticated for situations where protocols are stacked on each other or it's difficult. The green arrow that we put down here is also this approach. What sets up well, that green arrow is actually pointing to the S7COM function code, to the top level function code of S7COM. With this, you actually can extend to, if you're getting down to those rules with, that NSA was looking at in Rockwell, you can start with the first 3 to say, okay, let me make sure the packet headers that I expect are there. And then let me add in that green arrow to say, okay, is my top level function code in S7COM accurate? S7COM is a pretty complicated protocol. There's SCLs, there's a lot of other, functionality with it. And so as you're working through these rules, as you're tailoring down, depending on the operation on the PLC you're wanting to look at on these, your rules might get complicated, but again, you can look into how these industrial protocols work and very quickly get into, some really cool rules, some really tailored down rules. And when you're getting to this sophistication, again, why we went down to this depth is these rules are going to have lower false positives. You aren't going to go on as many wild geese chase. And generally they're going to be a little easier, especially for a resource limited group. We're going to go ahead and probably write some rules and try to put them back out to the ELITEWOLF repo over the next few days and week. So keep an eye out. We'll do a post on there. But what we wanted to talk through today really was what the ELITEWOLF rules were, the limitations, the strengths, ways to tailor them to your environment, and then next steps for them. So thanks for tuning in this week. It was great having you. We'll definitely have a video next week, and we hope to see you back then. Thanks.